Find the partial fraction decomposition of the rational expression. So now we're going to take a look at this problem here. This one's a little different because we have this x plus 1 squared. So this means I have a multiple of the same factor, which changes actually the way I do this problem. And we'll have to account for that, and I'll show you how that sum actually breaks up for us. So now the way we break this down is the x plus 2 stays the same. Nothing happens with that one because there's no other power here. Okay, so now when we look at this next one, because this is a squared here, I have to think about every combination of x plus 1 factors up to x squared. So that means the first one could be x plus 1. The next one could be x plus 1 squared. So that's kind of how it works. Now, if this was a 4, then I would also have a plus x plus 1 cubed. And then I'd have another one that would be x plus 1 to the 4th. So I'd have to put all of those in there when I have these multiples of the same factor. But we don't have a 4, so we don't have to worry about that. So this is as far as we have to go with this. So thinking about all of those different variations of that factor x plus 1 up to x squared. Okay, so now let's get into the other part. So now, because this denominator is linear, or I would say degree 1, that means the top would be degree 0, so that this is going to be an a. And this one here is also degree 1, so that means that's just going to be a b then up top. Now for the next one, we could see that if we multiplied this out, if we FOILed it out, that would actually end up being a degree 2 polynomial. But because we're dealing with x plus 1s, so we would follow the same pattern that we have for the first one. So that means this would just be a c, not a cx plus d, because this here is a degree 2 polynomial down here. Because it's multiple factors, multiple same factors, we always do what it was from the first. Now, if this was like an x squared in here and here, then this would be a bx plus c, and then this would be a dx plus e. Okay, so that would change it because this here is degree 2, so that would be a degree 1 up there. So that means even though this is a degree 4, we would treat it as a degree 2 as that first polynomial. But we don't have to worry about all that here. So this is what we're looking at. So I just wanted to let you know those things because that's how these multiple factors work that are the same. Okay, so anyways, so now on this one here, we're just going to do the same thing we did with the previous one. So now we have to add these together. So again, we're putting this aside for now, and we're just going to deal with the sum of these. So for this first one here, this x plus 2, we're going to have to multiply it by x plus 1 squared. So that means we multiply the top by x plus 1 squared. And then the middle one here, this one's going to need an x plus 2. And then also it's going to need an x plus 1 because this one on the end has 2 x plus 1s. Okay, and they all have to have the same thing when we're done here. So this one's going to need, oops, I almost forgot. That means the top is going to need an x plus 2 times x plus 1. And then this one on this last one here just needs an x plus 2. So then the top needs to be an x plus 2. Okay, so there we go. Now what we're going to do is we're just going to multiply these all out here and set them up for adding them. So then I'm going to go through all of this multiplication together, and I'm just going to show you the end result of this for the sake of time for the video. So anyways, so notice here that with this first part here, this here is going to have to be a FOIL because that's really x plus 1 times x plus 1. So I'm getting an x squared plus 2x plus 1. So I'm just going to go through and actually just show you the end result of these without going through them physically on the video. So there it is. So just keep in mind that these are FOILs here. And when I multiply those, then I multiply it times b for the first two. The last one is just a distributive property for the C. So now what we're going to do is we're just going to set up those columns like I like to set up here. So I'm going to say, hey, this is ax squared plus 2ax plus a, and then I have a bx squared. Now I know I'm adding all of these, so I have that in my mind when I'm actually setting these up this way too. Oops, that's a 3bx, and that's plus 2b. And then I have a cx plus 2c. Now again, like I said, I like to match them up according to the degree of the terms. So I have a squared, a degree 1, and then a constant on the end there. Okay, so now what we're going to do is we're just going to set up our equations. Now when I look at the original equation here, or the original expression, excuse me, this is really a 0x squared since it doesn't have one. So this a plus b here is going to equal 0. Okay, so that's going to be my first equation. So that's going to be a plus b equals 0. And now I'm going to look at the middle column here. So those are my x's. So it's going to be 2a plus 3b plus c. And that's going to equal the number in front of the x, which is 1 because I don't see anything there. So it's understood to be a 1. So that's going to be 2a plus 3b plus c equals 1. Now for the last one, I have a plus 2b plus 2c, and that's going to equal negative 3. So that's going to be a plus 2b plus 2c equals negative 3. Now when I look at these three equations, I could use a matrix and do a reduced row echelon form on my calculator. But what I see right away is I can take this and sub for a, b here, and then plug that into both of these here. And then from there, I can get two equations, two unknowns. So that's what I'm going to do here. So I'll take this one here, and I know that a equals negative b. Now I'm just going to take it and solve it, and not solve it, but plug it in for a, negative b into this one here and that one there. Now for the sake of the length of the video, I'm just going to write it out for you, and you'll see the end result. And if you need to pause it, that's fine. So here are the two equations here. So again, this one here was just the subbing in for this first one here that I did here on the right. And then this one down below here, this one is this one here. So those are my two equations now. So now I have two equations, two unknowns. All right, so now what I'm going to do is I'm going to solve a system of equations. So these are the two equations I'm looking at here, just so you know, so there's no confusion. And I can either do the addition method or substitution method. I think for this one, I'm just going to do the substitution method. And I think that'll be good enough here. So this is going to turn out to be b equals, and I'm using this one here, b equals 1 minus c. And I'm just going to take that and sub that in the top one here, or in the bottom one, sorry. So this means I'm going to plug in c minus 1 in for b there. Okay, so that's going to be 1 minus c, and actually I'll do it in a different color so you can see it a little more clearly. So 1 minus c plus 2c equals negative 3. Okay, so again, that's just this equation here. And instead of the b, I plugged in 1 minus c. Okay, so then that's going to be 1 plus c equals negative 3. So then c is going to equal negative 4. So c is negative 4. All right, now that I have c, I can find b because I know b plus c equals 1. So then again, my c is negative 4. All right, so then when I add 4 to both sides, I'm going to get b equals 5. So there's my first one, there's my second one. Now I need a. And I'm going to go back to the very first one here that I was working with, and that's way over here. since b is, well, a is negative b, then a would be negative 5. So there's the third one. So now that we have all three of them here, now all we have to do is set them up in our equation here. And I'm just going to do that right up on the very top here. And I'll do it in a red for our answer here. So this is going to equal. So this is going to be my x plus 2. And then my a turned out to be negative 5. So that's going to be a negative 5 up top. And then this is going to be my x plus 1, and that turned out to be my b there, which is 5. And then my c here is going to be the x plus 1 squared, and that turned out to be negative 4. Okay, so there's our answer. Now another way we could see this is, I could just take this off here and take the negative off that and just say, hey, this is just going to be minus that. And a lot of times you'll see answers that way. So there's our answer.